You ever watch an AI try to solve a problem and it feels like it's just running in circles? Thinking really, really hard but just not getting anywhere? Well, that's a huge problem in AI. It's called degenerate exploration, and it's been a major roadblock. But what if we could teach an AI to think smarter, not just harder? Let's dive into a new approach that is doing exactly that. So, what is this degenerate exploration anyway? Okay, imagine you're lost in a maze. It's like taking the same wrong turn over and over and over again, instead of just stopping, stepping back, and trying a totally different route. The problem is, the way we've been training AI, using reinforcement learning, can actually encourage that stubbornness. It leads to these long, rambling thought processes that go nowhere fast. It's basically AI underthinking. And this, right here, gets to the absolute heart of the issue. The whole problem is this obsession with depth, digging one super long, super specific, and usually wrong hole. What these models really need is breadth, the ability to be flexible, to explore a bunch of different high-level strategies to find the one that's actually going to work. So, how do we fix it? Well, meet RLAD. It stands for Reinforcement Learning with Abstraction Discovery. And it's a completely new way to teach an AI how to think like a strategist, not just a simple calculator. This is the key to unlocking how they can find the core procedures needed to crack really, really tough problems. Now, the secret sauce here is something called a reasoning abstraction. Honestly, the best way to think about it is like getting a killer hint on a crazy hard exam question. It's not giving you the final answer, nope, but it gives you this powerful high-level strategy that suddenly makes the path forward totally clear. And look, we're not talking about just random tips here. Think of it like learning to cook, right? You don't just memorize one recipe for one dish. You learn the fundamental techniques, like how to sauté or how to braise. And once you know those, you can create tons of different dishes. These abstractions, they're the core cooking techniques for AI reasoning. Okay, so how does RLED actually pull this off? Well, it creates a dream team inside the AI's mind. You have a brilliant strategist and a perfect executor, and they work together. This is where agentic AI really gets its superpower. So here's how the team works. First up, you've got the planner. Its whole job is to be the creative one, to come up with several different high-level game plans, or abstractions. Then the solver steps in. It's the super focused executor. It takes those game plans from the planner and uses them as a guide to crank out the detailed, step-by-step solution. It's the perfect combo of big picture strategy and focused execution. Now, that all sounds great in theory, but does it actually work in practice? Well, the results are, to put it mildly, pretty incredible. With RLAD, the AI starts to build this whole arsenal of problem-solving moves. It learns to generate things like caution alerts to steer clear of common traps, or find productive launch points to get a really strong start. It even discovers structural shortcuts to just leap over tedious parts of a problem. And get this isn't just for math. These strategies work everywhere, from healthcare to legal analysis. Just look at this chart. It tells you everything you need to know. It shows that if you have a lot of computing power, spending it on generating more diverse strategies, that's the big bar on the right, is way, way more effective than just trying to brute force more solutions down the same old path. It's the definition of working smarter, not harder. And the headline? How about a staggering 44% average improvement over the other best-in-class methods on a super difficult math reasoning test? Just let that sink in for a second. 44%. That's not a little tweak, that is a game-changing leap in what's possible. But look, that huge number isn't even the whole story. This points to something much, much bigger. We are finally teaching an AI how to build its own reusable knowledge, how to learn the process of solving problems itself. This is a massive step towards a much more general and much more strategic kind of intelligence. Which, of course, leaves us with this incredible question. As AI starts to shift from just calculating answers to actually generating its own novel strategies for discovery, what currently unsolvable problems in science, in medicine, in everything will it help us crack next?